Welcome back, children. Welcome to Refresh Concepts with me, Dinesh Modi. We start with our chapter understanding what do you mean by introduction to linear equation. Though we know that we are going to deal with quadratic equation, but I want you to understand first linear equation and then only proceed with quadratic equation. Now, children, what exactly linear equation is? Any idea if anybody can give me what's the linear equation definition of that, or any general formula or something of that nature? No? Okay. We say that linear equation is nothing but any expression in the form of ax plus b is termed as a linear expression. If I equate with 0, then certainly it is going to be an equation. So say ax plus b equals to 0 is termed as a linear equation in one variable. Mind you, what I have written over here is general form of, if you want you can write down general form. This is general form of linear equation, ax plus b equals to 0. Now there lies a condition over here, children, where a cannot be equal to 0. A cannot be equal to 0. I'll come to this particular condition after some time. But what's the general form of linear equation? General form of linear equation is ax plus b equals to 0. What do you mean by here a and b? What is a then? A is termed as coefficient. What is A? A is coefficient. Coefficient of what? Coefficient of variable. So what is x? X is nothing but my variable. X is nothing but my variable. Then what is B then, sir? B is any constant. What is B? B is any constant. So what exactly linear equation is? Linear equation in one variable is when we have an expression or an equation ax plus b equals to 0, then we say it's a linear equation in one variable. The condition is a should not be equal to 0. What is a and b over here? A is the coefficient of variable x. X is nothing but the variable. B is any constant. Now my children must be wondering that why this is termed as linear. It is equation in one variable, then why we are giving the name as linear? Children, we just need to look at the degree or the exponent of the variable x. If nothing given, so what is that? Highest degree is 1. Since the highest degree to the power is 1, we say it's a linear. Linear means 1, right? So whenever the highest degree of the variable is 1, it is termed as a linear equation. That's the reason we have linear equation. And we have only one variable, and that's the reason I keep on saying this is linear equation in one variable. Now, there are many students who must be wondering that what values of a and b it can have, where a and b can have any real values, where a and b can have any real values. So that means you can say any real numbers, where a and b can be any real numbers. Now I'll come to my point, which I said in the starting of the general form. What it is? Ax plus b equals to 0, where a should not be equal to 0. Now why we have this particular condition? If a were to be 0, children, if a were to be 0, 0 into x will give me 0. The entire first part will be 0, and we are not left with any variable. In fact, we are not left with any equation. Then b is only constant. B is only constant. So that's the reason we say that a should not be equal to 0. The moment a is 0, we don't have the linear equation in our hand. We don't have linear equation in our hand. One more thing is what you can extend this by saying that the same expression can also be written as ax plus b equals to c. Rather than 0, we can always have one more constant. Not necessary that every time a particular linear equation will be equated to 0. No, not necessary. It can be equated with any constant also, right? So we can have ax plus b equals to c also as a general form of linear equation. What could be the example of the same? I'll just give you an example. I would like to give you an example over here. What could be the example here? Say for example, 7x plus 5 equals to 19. 7x plus 5 equals to 19. 7x is equals to, when 5 goes over there, 19 minus 5, 14. On dividing by 7, x is equals to 2. That's how we have solved a very simple sum of linear equation. since it has only one variable, we'll have only one answer. Since it has only one variable, we'll have only one answer. That's what I think so you'll have studied in your lower classes, right? Now let's understand what do you mean by linear equation in two variable. So up till now, whatever we did was linear equation in one variable. Let's proceed further. Linear equation in two variable. Now what could be the general formula of linear equation in two variable? Children, linear equation in two variable is nothing but given by ax plus by equals to c. Ax plus by equals to c. Unlike I have not taken over here 0 as we had taken over here, as I said thereafter also, I can have any constant. I can have this particular equation equated with any constant also. So what is the general formula? The general formula is ax plus by equals to c. This is what we are talking about. General form of what, but children? General form of linear equation in two variable. Now what is a here? A is nothing but, as we have written down, coefficient. Coefficient of what? Coefficient of variable x. What is b? B is also coefficient of variable y. Then what are these x and y's? X and y's are nothing but my two variables. X and y are nothing but my two variables. That's the reason, two variable. And what is this c? This c is nothing but any constant. This c is nothing but any constant. Now you must be thinking that sir hasn't written down any restrictions or conditions over here. Indeed, the conditions are getting applied. What was the thing? Ax plus b equals to 0 where a not equal to 0 in one variable. Absolutely on the same line. The condition applied is where a cannot be equal to 0 and b also cannot be equal to 0. Here a cannot be equal to 0 and b also cannot be equal to 0. Let's check. What if a is 0? If a is 0, this is 0. I am left with only one variable. So my two variable transforms to one variable. If a is having some value and b is equals to 0, once again I am left with one variable. And both really cannot be equal to 0 because then I'm not left with any kind of equation. I'm not left out with any kind of equation. I hope my children are understanding how we are going further with this. Finally, again, what values a, b and c can have? A, b and c can have any real values. C can have, a, b and c can have any real values. So if you want, I'll give you a very simple example. Say 3x plus 2y is equals to 10. 3x plus 2y is equals to 10. This is an example of linear equation in two variable. 3x plus 2y equals to 10. Whenever we have two variables, we have to have two equations. I have just shown you one equation. There will be two equations which we need to solve it simultaneously. It's a total different game. That's what we are going to study under simultaneous linear equation. But only to make you understand how it is presented, then this is an example which I have given you. I haven't solved this. We will be having two answers. An answer for x, an answer for y. But for that, we need to have one more equation that needs to be solved simultaneously. I hope my children have understood what exactly linear equation is in one variable, in two variable, and what are the conditions applied.